In order to find the area between two curves, we just need the formula of the integral of top minus bottom. That's all we're going to be using to figure out whether these three statements are true or false. So here we're looking for the area A1. Note that A1 is given by this function, this dotted line function, which is g of x, and the bottom part of that function, or the bottom part of that area, is this line y equals 1. So I'm going to go say y equals 1 there. In this case, top is g of x, so integral of g of x, minus bottom. In this case, bottom is 1. So we have g of x minus 1 dx. And while at first glance that might seem like that doesn't match this answer, because after all this says minus 3 as opposed to minus 1, this is because the minus 3 has already been produced from the integral. That is to say, this negative 1 we can integrate. We know how to integrate g of x minus 1 from 1 to 4. Now we don't know g of x, we don't know what that function is. We're going to have to leave it as the integral from 1 to 4 of g of x. But we can integrate negative 1. And in fact, the integral of negative 1 from 1 to 4, that will be 3. Let's go ahead and quickly compute that. Integral of negative 1 is negative x. Plug in 4, plug in 1, find the difference, and we get negative 3. So this actually ends up being true. G of x minus 1, it gives us the area sandwiched between these two, A1. And when I integrate g of x minus 1, I can't integrate the g of x because I don't know what g of x is, but I can integrate the 1. And the integral of 1 is x. Doing that from 1 to 4 gives me negative 3. Okay, how about A2? A2, we have to figure out what two things are bounding the functions, or the area given by A2. This is A2. This function above would be y equals 3, and the function below, bounding the area below, is f of x. So this is f of x. So in order to find that area, I'm going to say the integral of top, which is 3, minus bottom, which is f. So 3 minus f of x dx. Now once again, this might not look like the answer because there's a 3 here and there's a 9 here, but you have to remember this 9 was produced as a result of integrating that 3. And again, over the bounds from 1 to 4. So integrating 3 gives me 3x. Plug in 4, plug in 1, find the difference. 3 times 4 is 12. 3 times 1 is 3. 12 minus 3 is indeed 9. So I get 9 minus f of the integral of f of x evaluated from 1 to 4. So this is also true. And lastly, we have A3, which is the area sandwiched between this top curve, f of x, and the area sandwiched between this bottom curve, g of x. So make sure you have f of x minus g of x inside your integral. Otherwise, if it's a reverse order, it would be false. But this case seems to be true. We have f of x on top, which is the top function, and minus g of x, which is the bottom function. So this integral checks out, and it seems like all three of these are true.